Hey guys, welcome to Safi Mixed. You learned in our previous video that when we multiply a number with a vector, the number can change the magnitude of the vector, the number can change the direction of the vector, and the number can change both the magnitude and direction at the same time, but the multiplication of a number leaves the nature of the vector unchanged. However, when we multiply a scalar with a vector, then that's not the case. The scalar multiplied with a vector changes the nature of the vector. And that is very important that you must note. When we multiply a scalar with a vector, it changes the nature of the vector. In fact, the multiplication of a scalar with a vectors is a two-step process. First, the scalar changes the nature of the vector, and then it changes as per its own way the magnitude accordingly. For example, if we have velocity v of a particle and we multiply this vector with a scalar t, which is time, then we know that velocity can be characterized by three entities. Number first, a number which we write, let me write that number as m. M is a number. This number multiplied with unit, and then with direction, a unit vector. So these three things jointly represent this velocity. And then we multiply this thing with the scalar. The scalar can be represented by two entities, by two things. One I call a number, which I write as n, and the other, it's units. So it's unit, which I write as unit of time. Now, what happens when we multiply a vector by a number? This number and this number multiplies with each other to make another number, and m times n is another number. Then this unit time is another unit times another unit is a third type of unit, and then this unit vector we write at its own position. Now, this unit time is another unit, and we know when the unit changes, the nature of the quantity changes. And from here, we know from our mechanics that the product of these two entities, these two physical quantities, is another physical quantity which we call distance. So in fact, the multiplication of a scalar with a vector has changed the nature of this vector to the nature of distance. So if I use the exact values in this case, I can write that the s is in fact equal to this thing. I call this n time n another number. Let's say I call it k. K is a number, and the units of velocity is meter per second multiplied with the unit of time, which is second, and then unit vector v. So this second with this second cancels, and we are left with k times unit vector v measured in meter, the unit meter. So in fact, the multiplication of this scalar with this vector has changed the unit from meter per second to meter, and from meter per second to meter mean we move from one type of physical quantity to another type of physical quantity. Now, it depends on the weight of this number of this scalar, that is this thing. This is the weight. This weight means this the worth of this number. If it is larger, it will change the magnitude of this vector by a large amount, and if it is smaller, it would accordingly change the magnitude, that is, which is k of the distance, by a small amount. Now, if you recall, whenever we multiply a scalar with a vector, the scalar is always a positive entity. For example, time is always positive. Similarly, when we multiply mass with acceleration, the multiplication of mass with acceleration changes the nature of acceleration to force. which is in fact Newton's second law. But mass is always a positive quantity. Similarly, if we have volume, which is a scalar quantity, pressure, which is a scalar quantity, all these quantities are in fact positive. They are treated as positive numbers, positive real numbers. So on that basis, we say that when we multiply the vector with a scalar, it leaves the direction unchanged. They are in the same direction. In fact, I want to conclude this, that when we multiply a scalar with a vector quantity, the scalar changes the nature of the vector quantities. It changes one vector quantity to another vector quantity. Thanks for watching.